college college exams and I was doing other stuff. But from now, I'll try to be as much consistent as possible. Thing is, let me just set the context of this video. From here, at this point, I'm gonna start this intuition building playlist in DSA, and we'll cover eventually every advanced topics. First topic which I'm gonna cover is recursion. And why I chose this topic, because I just want to cover only advanced topics which will eventually help me to learn things. So yeah, if you are someone who is dedicated to CP, probably not the best place for you to start, but if you start, you will get a good idea about how to solve any problem if you are going for interviews, if you are doing any interview, or if you are participating in any placement drive or something else. This thing might eventually help you, because intuition building is something which help in CP as well. So I'm not going to cover basic, like some standard CP problems. We will eventually cover it once we cover this series. The backend development series is also there. I'll cover it as well. I have shot some videos also, but it is in, like, there are some patches there. I need to fix the editing stuff, and I will upload it. So this was it, and let's just jump over to this problem only. The problem which is given as, you are given an array which is nums. So suppose you are given an array and you need to generate all the subsets of that array. So suppose if you have given nums is equals to 1, 2, and 3. So we all know what are subsets. What uh, possible subset possible subsets of this particular array can be an empty subset, can be 1, can be 2, can be 1, 2, 3, 1, 3, 2, 3, and 1, 2, 3. This whole array is also a subset of it. If you are given n number n total number of subsets, if you are given an array of size n, basically the total number of subsets can be 2 to the power n. Got it? That's it. Just think about how we will solve this problem using recursion only. Basically, there are various ways to solve this problem. Why recursion? Why to use only recursion only? The thing is, the best place or the best thing to learn something is to learn it on the go. Just learn it, experiment with it, and eventually, when do you try to experiment with things now, you will get the idea that why we chose this particular approach only. So that's what we will do. We will solve this problem using recursion, and at the end of the solution, you will get to know that, oh, this is the reason why we chose recursion. Okay, so let's just jump over to this, how we will approach this problem, how we will solve, and eventually at the end of the day, we will write the code and submit it. So let's just start. Okay, so now let's just head over to, like, now let's just head over to solve the problem. So the thing is, problem given to us is, I am given a that I am given an array. So from here, 1, 2, I am given an array. Simple. Whenever you are trying to solve any problem, try to just solve it with basic examples, and then eventually raise the bar to solve, to just try run that problem on big test cases and advanced test cases. Okay. So the basic example is 1, 2, 3. Yeah, I could have also taken this 1 and 2 size array example also, but that is very basic. You won't actually get the crux of this approach. So that's why I took this, and eventually LeetCode also used this. So that's it. That's why. Now try to think recursively. Now what does recursively thinking means? Recursively thinking means that whenever you are given any problem which tells generate all this blah 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 blah, generate this xyz, always remember, from an interview perspective, problem can be solved by recursion. It can also be solved by DP. Just think Just fit this thing in your mind. Generate all means there is a recursion thing on code. Why? The thing is, I have given this array and I have to generate all the possible subsets out of it. And what are the possible subsets? These are the possible subsets. This particular array, which is 1 to 3. Okay, so these are the possible subsets. These are. Okay, an empty array 1, 2, 1, 2, 3, 1, 3, 2, 3, 1, 2, 3. Now, how these subsets generated? Basically, theoretically, we know that what can be the subsets, but how this eventually fed how we eventually fed this logic as a code and then eventually get the answer. You can see, just try to understand a particular approach at every point. If I am this particular at this particular index 1, if I am this particular index 1, I have a choice that either I can take this element and I won't take this element. So thing is, suppose I am given this. This is the like example which I have been 1, 2, and so suppose if I have this example 1, 2, and 3, I have some choice. What are these choices? If I what you can do is at every point you have some choice. Either you can take this element, either you can take this element, or you don't take this element. If you don't take this element, suppose if I just don't take this element, if I just don't take this element, then I just remove it and I have these two elements left only, 2 and 3. Okay, so I have here, I also have 2 and 3, these two elements left only. Here also also I have two choices. Either I can not won't take this element or I can take this element. So also here also I choose that okay, I just don't want to take this element. So okay, then only you have element which is left is 3. This is the only element which you have left, which is left now. So here also you have two choices. Either you can take this element and you won't take this element. Okay. So the thing is, if I don't take this element, what will happen? And if I take this element, what will happen? So I say that okay, I just don't want to like take this element. So I also choose that no, I just don't want to take this element. You have no choice now. You have like left like there is no choice available because eventually you started with this one, then you jump over to this element, then you also jump over to this element. Now you don't have any choices left. The thing is, I at the first when I was at this particular element, I had two choices. When I jumped, I chose no. Then I jumped over to this. I also had two choices, but I chose no. Then I jumped over to this element. I also had two choices. I jumped over to this last. This I exceeded my array size. I just my iterator which was pointing to my array. I just traversed through every element, and I did not have. Now I just don't have any choice. So the first possible solution you have got your first possible solution here. This first possible subset which I've got, which is empty now, because when I was at this first element, I had two choices, no or yes. And suppose there is a temp vector in which I am storing what can be a possible subset. If I have chosen yes, I could have taken one in this temp vector, but I did not choose one, so I won't take this. Then I jumped over to this. Also, I had no, so I did not took any element. When I jumped over to 3, I also had two choices. I chose no, and I did not put 3 also in this array. This is an empty array, and I have traversed the whole array. And if I have traversed the whole array, The current value of temp, which is this empty, which is empty now, is a possible subset. Congratulations, you have got your first possible subset. So if I go here, you can see the first possible subset is empty, and an empty array. This is how it is being done. So if you are getting confused, let's just try to understand it with a flow chart, a flow graph. Try to understand it with that. Okay. So currently, suppose index is pointing to this particular one. This is where my current index is. My index is 0, and this is the first element which I am at right now. And I have two choices. The two choices are either I won't take this element, cool. Also, I have another choice, I can take this element. Okay, these are the two choices which I have. So, what are these choices? Choices are no and yes. These are the two basic choices which I have right now. And now my iterator, now my index will be incremented by 1. Now my index will be incremented by 1. Okay, so now my index will be increased. Now this is the current element which I am pointing to right now, and it's a recursive call. So I had two choices, either I won't take this or either I can take this. I chose the first part. The recursive call goes to another function. Here I am pointing to this particular index. I have two choices, no or yes. Okay, here also I have two choices, I can take this element or also I won't take this element. These are the two choices which I have. That okay, don't take this and can take this. I said that no, I just don't want to take this element. I want to don't want to I just don't want to take this element. Okay, you just head over to another element. Now try to now my index currently pointing to 3. This is where my index is now. This is the current element which I'm pointing to. Here also I have three choices. Okay, you can take this, you cannot take this. I say I won't take it. If you are still confused, basically what I'm trying to make you understand is, if I suppose you have an array 1 and 2, you have only you have an array which has only two elements, 1 and 2. Here, what are the possible solutions you have? What are the possible amount of choices you have? Choices you have. What are these choices? The choices are, bhai, how how can I make a prediction, or how can I make a choice so that I can generate some amount of subsets? If I have only two elements, so I will have four choices. Now, what are these choices? Ki bhai, the first choice which you can have, ki you take only first element. Bhai, only take first element. Okay, I took a first element. This is a possible solution. This is a possible subset. The second choice which I have is take the second element, don't take the first element. So the possible solution. The third choice is take the both elements. These are the possible subsets, and these are the three choices which I have. But in every question, in every possible test case, there is a default choice which I have, that I won't take any element. This is a possible choice. Now you don't take any element. A possible choice, a possible subset. So in this case, that possible subset will be empty. These are the four choices you had. And from these four choices, you generated four subsets. Are you getting any pattern here? That here the number of choices, the number of choices is eventually equals to number of subsets. This is the first tick mark. This is the first tick mark which you need to. Yes, the number of choices is always equals to the number of subsets. So if I have been given n size array, I can make n choices, and in every, not n choices, number of subsets. Now what can be number of subsets? If I am given n size array, the number of subsets is 2 raised to power n. I can make, if I have n size array, I can make 2 raised to power n choices, and these 2 raised to power n choices will eventually help me to get to these subsets thing. If you have n size array, these 2 raised to power n choices will help you to get every possible subset. So if I have a array size from this example, the size which of the array is given as 3. So if I have array size as 3, if I have 3 size array, then the number of subset is 2 raised to power n. So 2 raised to power 3, which is 2 raised to power 3, which is 8. So I have 8 choices, which is equals to 8 subsets. Yes, this is what the basic thing which I want all of you to understand. Let me just take a break. I need to something. ओके, कूल। यहाँ तक समझ में आ रहा है कि भाई पहले मैं फर्स्ट इंडेक्स पे था, आई हैड टू चॉइसेस, इधर आई वोंट टेक दिस एलिमेंट और आई विल टेक दिस एलिमेंट। फिर मैं सेकंड इंडेक्स पे आया, सेकंड एलिमेंट में पॉइंट कर रहा हूँ, आई हैड टू चॉइसेस, इधर आई वोंट टेक दिस एलिमेंट और आई कैन टेक दिस एलिमेंट। ओके कूल। फिर उसके बाद मैं थर्ड एलिमेंट पे गया, आई ऑल्सो हैड टू चॉइसेस इधर। ओके, सो हियर व्हाट हैपेंड, व्हाट द फक। What is this? Okay. यहाँ तक समझ में आ रहा है कि आई हैड सम अमाउंट ऑफ चॉइसेस एट एवरी पॉइंट। हर एक पॉइंट पे दो ही तो चॉइसेस है, या तो एलिमेंट नहीं लूंगा या फिर एलिमेंट लूंगा, या तो एलिमेंट नहीं लूंगा या फिर एलिमेंट लूंगा। और हर एक चॉइस एक रिकर्सिव कॉल को रिप्रेजेंट कर रही है। So the thing is, just try to understand this. Every like every choice represents a recursive call. That's what I want all of you to understand. Here, I have a choice, no or yes, a recursive call. I have a choice, no or yes, a recursive call. I have a choice, no or yes, a recursive call. So, what is this recursive call? If I try to understand it in terms of function, like let me just try to draw this. If I suppose this is a function body, something, anything, no, anything random, some code is written. This is the function body. Okay, you have some choices here. Suppose this is a no choice. Suppose this is a no choice. Basically, the same function call कि भाई I won't take this element. Increase the index by 1. Increase the index by index plus 1. I just don't want to take this element. Okay, index plus 1. We called the function again. Here, the function call itself. Here, the function call will happen, and it will just call this same function again. So the function call will happen, and eventually we'll call this same function again. Understood? This is how it will happen. We will understand this again after we will get to this that particular approach, but this is the basic understanding you can get ki at every point I have a no choice, then I'm calling this also I have a no choice. There will be n number of choices here. There will be eventually n number of choices here. If I just try to do it, it will call it like if I have three elements, I have three no choices. Suppose you have three elements, so you have n no choices. So you will call this thing n times, and eventually you will get to the end of the array. So here at this point, after calling this, suppose you get to the end of the array, and after when you reach the end of the array, you will eventually realize that oh shit, I have traversed the whole array. I have to return back. So when you will return back now, when you will return back, what will happen? The moment you will return back, the call to this parent function, the to this call to this parent function, call to this parent function will happen again. Hey, you have traversed whole amount of no choices. Now just take yes choices. If I take the yes wala choice, I have to insert that element. It might be a little bit overwhelming for you. Just forget about it. Just forget about it. You will just try to understand it more in more depth. So this is how the code was. 1 2 3, I had two choices. Now this is where my current element is. Okay, current pointer, this is where I'm currently pointing to. I can then now switch. I can now increase the index again by 1. If I increase the index again by 1, so eventually what will happen is, what the hell is this guy? So this is it. So now I am at this third index. Here also I have two choices. Either I can take this no, or I can either I won't take this element no, or I can take this yes. These two choices I have. Okay. So either I won't take this or I can take this. Choice I have, and these are the choices. No, and this yes. These are the choices which I have. These are the choices which I have. If I look at here, what I see is okay, if you choose no, so you will increase your index again. So here my index here, like look closely, the index will point index will equal index here, index will be equals to here at this point, index will be equal to size of size of ARR. Yes or no? Here index will be equals to size of ARR, because this is index 0, this is index 1, this is index 2, index 3, which is equal to size of ARR. I have traversed the whole array. So and I by choosing this no 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 no, and I have like now I am at the end of the array. I have traversed the whole array. I don't have any choice now because I have traversed the whole array, so I don't have any element left as well. This is what is known as base case of any recursive function. This is what this thing here, this is this is what known as this is what known as base case. Base case. Now, what is this base case? Bhai, you have traversed the whole array. You don't have anything left. Whenever I reach any base case, I need to return from the function. This is the recursion tells us कि भाई just return from the function. Just return from the function. But before returning, make sure you have a certain amount of subset left with you. Now I need to return something like this. I What happened? You just look at this subsets. I need to return an array of array. I need to return an array of array which has subsets in it. Okay, so here I have this thing. I have reached to this thing called base case. So I need to return. Before returning, make sure you have an ANS array. You have an ANS, this whole ANS array. Now, what does this ANS array consist of? It stores basically, it stores all the possible solutions which can be generated. This is the ANS vector. Okay, it stores all the possible solutions which I can generate. So when I was at this particular point, I was at this particular point. Suppose I also need a temp array. I also need a temp array. What does this temp array means? Because whenever at any point I need to some set of subsets, so I am at this particular element, I have some amount of choices. I also have a temp array. Why I have this temp array? I need to store the subsets as well. Eventually I will store the subsets in this temp array, and then after at every iteration, I whatever subsets I have, I will store it in my ANS final vector, final array also. So here I had two choices, no or yes. I chose no. So if I chose no, I will say okay, no problem, my temp array is empty now. Move to the second element. When I moved to this second element, I also had this temp vector with me. I said okay, no, I just don't want to take this element. So I chose no. So when I chose no, I said okay, if you don't want to take these two elements, your temp array will still be empty because you chose no. You don't have any element left. Then I move to this last element. Also here I chose no. I chose no. So there is no element in my temp array. So I reached to this particular point. Here my temp array is left and I reached to this base case. I need to return from the function. When I am returning, I have a some amount of subsets left with me. Here this is the subset left with me. It is empty. So what I have to do is, this is a possible solution. Whenever I reach base case, I will get a possible solution. This is the possible solution. This is a possible solution, and just put it into your into your ANS. What is my ANS? This is where my ANS is. Put it into your ANS. This is a possible solution. So this is a possible solution. This is a possible solution. This is a possible solution. Possible solution. Possible solution. Now you have reached to a base case. The function will return to its parent function. At and you know, at every point a choice is something which is a recursive function. So I will return to this parent function, which is this. Is this where my index was pointing to this last element? I have returned to this parent function, and here I also have this temp array with me. I chose I chose no. I reached to this base case, then I returned back. So I have only one choice left. What is this one choice? Which is yes. I have to take this element. This is the case. This case here states that ki bhai, you have to take this element now. You don't have any option left. You have to eventually take this. You have iterated through all the no choices. You reach to a base case. Function will eventually return. Now there is only one choice left, which is yes. So what you do? Take this third element. This is the only thing you have. So if I choose yes, if I choose yes, in yes, I have to eventually, what I need to do is, Yes, I have to take this element. So insert 3 in this temp array. You have inserted 3. Now you have inserted 3. Then again move. I have again moved by one index. So if I move by one index, like this, if I move by one index, now my current iterator will point to this. Yes or no? Just change the color. Now I will reach at the end of this array again. So now you also don't have any choice. This is also a base case here. This is also a base case. This is also a base case. You have to return back, return back, return back, return back. But before returning, make sure whatever solution you have, which is 3, you put it into your ANS vector. I have to put this possible solution into my ANS vector. This is also a possible solution. Okay. This is also a possible subset. And I have reached to a base case. I need to return. When I return back, I have traversed through all these choices, a no choice or a yes choice. So I have to return. So when I return back, I return to this particular function. This particular function is my parent function. Okay. Now this is my parent function. I traverse through no choice. Now I have to traverse through a yes type of choice. So let me just this yes choice will eventually tell me, I whatever element you are at, insert it into your temp vector. So I am at this second element. I have to take this, insert it into this. If I take this, so just take this element 2. Okay. Now I took this element. You took this element, and this again increase your index by 1. So again I have to increase my index by 1. Now here what will eventually happen is I have two I have two choices here, a no choice or yes choice. My index here, I need to increase my index as well, na? So here what will happen is this is where my index will go, the last point. Here also I have two choices. Here also I have two choices, a no choice as well as yes choice. Here also I have two choices, a no choice and also yes choice. If I choose the no, this is the same thing which will happen. I was at index 3, I chose no, I reached to a base case. Okay. So I will reach to a base case. At base case, whatever the whatever is in the temp vector, just suppose that that is your possible answer. That is the thing which you need to consider. So thing is, okay, here I was at this second index, then I increase my index by 1. I move to this last index. Okay, समझ में आ रहा है? Okay, तो यहाँ तक समझ में आ रहा है? ठीक है. So now I have reached to this last index. Here also I have two choices, no or yes. And the same thing is happening here. Like when I was at this last index, I also had two choices, no or yes. I chose no. Here also I am at last index, I have two choices, no or yes. And I choose no, I reach to a base case. Whenever we reach a base case, we need to do something. We return it, and when whatever we have in temp, we insert it in our ANS vector, ANS array. So I have reached this last index. I have to no choice. I will eventually reach a base case. I have to return. The same thing will happen. But before returning, what I have to do is I have to what put inside ANS whatever I have in my temp vector. So what I have to I have to put this two only. And what I have to put this two only. Okay. So that's what I will do here. What is this? Okay, so I have to put this. So let's just put this here. This is also a possible solution. This is also a possible solution. I have got three possible solutions till now. The empty vector, okay, the three and the one. These are the possible solutions which I have got till now. Now, this is the piece which I have covered. When I choose yes, if I choose yes, what I need to do is I need to put whatever I have at this current index to my temp array. So what I will do is कि भाई तू तो already था. I am at this current index which is 3. So I have to put 3 again. I have to put 3 as well. That's what I need to do. So this is what I will do as well. So I will insert this 3 also. This is a temp vector which I have got. From here only, I also have two choices. Okay, I reach to this particular condition. I have two choices. Either no, yes. If I choose no, I am this particular index only. I am at the last index. If I choose no, like I am at the last index. Okay, and if I choose no, I will reach to a base case. Whenever I reach a base case, I have to make sure that whatever I have in my temp vector is simply insert it in the ANS and then return. So I have this. So I will put this only. What I will do is I will put here. What this is the possible solution which I have. This is a possible solution. 2 and 3. Here, this is a possible solution. But if I choose yes, which I already did that. So I increase the index by 1. Call will return. Here also the call will return, and I will reach to the parent function. What is the parent function? This was the parent function. This yes call is happened. These both calls have happened eventually. So what is the thing which is left now? The primary, the prime and the first recursive call where the recursive call where happened at index 1. So this is the parent, this is the most parent function which eventually called these recursive calls. You can see. So now I have covered these no cases. This is the part. I have covered these cases. No वाला सारा case मैंने cover कर लिया. What I think the thing is left now is this yes वाले cases. ठीक है? So we will do this now. Now what I choose is take one. Take one in your TM factor. So here, hmm, here I have this temp. This is the temp vector which I have. If I choose yes, first thing which I need to make sure is insert this 1 into your temp vector. Okay, you choose 1. If you insert 1, you reach an index by 1. This is what you do. So I will again increment an index. I will reach to this 2 wala point. Here also I have to no and yes wala choice. If I choose no, same thing which happened will happen here. Eventually it will happen here. And what I have to do is I will reach a base case. Whenever I reach a base case, whatever I have in my temp vector, I need to insert it in my ANS. Here I will have 1. This temp vector will not be empty here. So what I need to do is I have to eventually insert it into my temp vector. This is this possible solution also. This is also a possible solution. Okay, then if I choose no, these things will happen. Okay, so you might get overwhelmed here. Let me just try to explain again. Now I am at the second index. Okay, so let me just try to make you understand by this example. Now here I am this second index. Here I have two choices. Here I have two choices. Either I can choose one, either I can choose like. So we have understood till here. Let me just remove these parts so that we will be able to understand it much better way. Okay, so now I am at this yes wala case. Okay, so I have two options. Yes, so I have inserted 1 in my temp vector. I reached to this particular array. Here I am at this second index. The first index and the second element. I have two choices here. A no wala choice and a yes wala choice. No wala choice and yes wala choice. So let me just no wala choice and yes wala choice. If I choose no, if I choose no, I will reach to an index by 1. Now my iterator will point here, the last index. Here also I have two choices. Here also I have two choices. Either I can take no or I can take yes. These two choices I have. No, and I can take this. If I choose no, what will happen is I have to again increase the index by 1. So let me just, if I choose no, so this is the array. Okay, so here if I choose no, my current, like my iterator will point to the last index of this array. So here also I have two choices. If I either I can take this element or I won't take this element. The same pattern will happen. You can see the same pattern is happening again and again and again. This is for the no control. Okay, so this thing will again happen. And if I choose yes, let's just take this element. So again the same thing will happen. Okay, now I just don't want to take this element. Don't take it. Before leaving it, make sure ki you have whatever the current value of temp. So if you don't want to take this, eventually what happens is your iterator will point to the end of this array. The same thing will happen. So whatever you have currently in temp, so this is the one I have currently temp. So this is the one I have this one only currently in my temp. Put this into your ANS vector. So I put it into my ANS vector and then this return will happen. I will head over to this particular yes wala case. I was at index 3. So whatever you have at current, if you in your temp vector, just add that current element. That current element is 3. eventually that is the current element is now 3. Add this to a temp vector and move by one index. So if I will move by one index, I will reach again to the end of the array and eventually return will happen. So before return will happen, what we have to do, we have to put the current temp value into my ANS vector. So this is the current temp value. I will put it into my ANS vector. So I will put this 1 3 into my ANS vector. Possible solution. Okay. So this, you can see here, this recursion call has successfully happened. This successfully happened. Okay. Now I will reach to this particular case. Let me just try to make you all understand. So this is the case. Is this yes wala case will happen now. What will happen here is whatever the current temp value, which is 1, and where you are at, I am index 2. Just simply add this. Simply add that into your temp vector. This is the current temp value. This is the current temp value, and I am at index. I am at the second element, so index is pointing to the second element. I have to eventually add this. So this will what will be returned as an answer. Like this is what temp vector consists of. Again, here I have two choices. I will have two choices. In here also I will have two choices. Here also I will have two choices. Either I can take this or I won't take this. No, and same yes wala case. I can take this and I will not take this. No, yes, yes. But eventually you will notice that I was at second index. So I chose yes. So you choose 1 and 2. But eventually where my iterator will point now? Where my iterator will point now? So now my iterator will point to this last index. This the 3. This is where my iterator will point now. This index. So I have two choices, either 1 and 2. And what is the current value of temp? This is the current value of temp. This is the current value of temp. This is the current value of temp here. Current value of temp. Okay. So I chose no. So when I choose no, I will reach the end of the array. I will reach to a base case. I have to add this temp array to my ANS vector. So I just add this. Where is the ANS? This is the ANS. This is where the ANS is. So and 1 and 2. This again no case. If I choose yes, this is the current value of temp. This is the current value of temp. This is the current value of temp. So I have to add the current element. So if I choose yes, I have to add the current element, which is 3. So this is 3. Again, I have to add this. And why I have to add this? Because I added this. Now iterator will, now the same iterator will, now the iterator will point to the last index, empty index, the empty the subspace, like the iterator will throw iterate the whole array. It will point to the size of the array. Basically, there is no index here. Basically, there is no element here. I have traversed the whole array. There is a segmentation fault if I try to access some element beyond the boundary of array. So this is a base case again. So this is a base case again. So what will happen is I have to add the current value of temp. This is the current value of temp. This is the current value of temp at this point also. So I have to add this. I have to add this in my ANS vector. Where is my ANS vector? This is ANS array. This is the current. This is my ANS vector. I have to add this 1 2 3. Okay. So here also you can see this call. This whole call has happened. You can see this whole call has happened again. Okay. This call has happened again here also. This call has happened. This yes wala, this whole case is resolved. This whole case is resolved, and eventually it will. Eventually, what will happen is this case happened. This case happened. I will reach to this base case. If yes wala case happened, I will reach again here. I have eventually now I have completed both the cases. I have completed both the cases here. This is the point. I have completed both the cases. Okay, so I will eventually my parent, the parent function, this was the parent function, this was the parent function, will eventually return, which will eventually return, and I will get my whatever the current state of my ANS at this point. This is the current state of my ANS at this point. I have 1 2 3 4 5 6 7 8 8 sub arrays in this ANS array. This is the answer, and this is at this point I will get my total number of subsets. Now let's just try to code this approach. Let's just try to code this approach. Just head over to LeetCode. Now let's try to code this. So what is solution is, I have to take an ANS vector which I will return, and that ANS vector is a vector of vectors, a vector. If you are using Java, you basically use array list kind of thing. So vector of vector is ANS. It will store all the subsets. Then a temp vector to store the temporary array, to store the temporary subsets. A temp vector. Let's just say index is equals to nums dot size. The size of the nums is n, and this is it. I think this is what we need. Now we will return when we have to generate all the subsequences. So let's just generate all subsequences. Generate all subsequences. Now let's just generate all the subsequences. What I have to do is, here I have to pass this ANS, then this temp, then this nums. This is all I need. I will need, then this n, and my current index, where my, this is, if suppose this is the nums, this is nums 1 2 and 3. So my current index will be 0. This will be my current index, which will be 0. This function will generate all the subsequences, and now let me just return ANS. So this ANS will now at the end of the day will consist all the subsequences. That's it. Let me just write the code logic for this. Now what this function will do, this function will eventually manipulate, will do some manipulation in ANS. It will be a void function. So void all subsequences, sequences. So here what I did was, I will pass this ANS. So I have to do some changes in array, in this ANS vector. So every time a new temp will generate, I have to add this to ANS. So I have to pass it by reference. Vector int ampersand ANS. Okay. Then I have to pass this. There will be a temp vector which will store all the subsets. Then this current nums array I have to pass. Then whatever the size of the array, int n, and this int index. This is which is currently 0. This is it. You can see, and you notice that at every point I had two choices. Either take it or don't take it. So I will not take it first. I will not take it. All subsequences I won't take it. I just won't take this. So if I just, when I just don't take this, what I do, I just simply increase the index. If I don't take any index, whenever I choose no, I simply increase the indexes. Okay, that's what I do. I will increase it. I will increase the index. Same ANS, this temp, this nums, and this n, and simply increase the index by 1. Okay, at some point index will reach to a base case. Something index, like I will traverse the whole array by using this no-wala approach, and I will reach the end of the array. Whenever I reach the end of the array, whatever I am at, so here index, so this is where the base case will happen. If my index will reach equals to n, yani jab index crosses the boundary of array, what you need to do, you need to simply return. But before returning, make sure कि आप ans के अंदर ans dot pushback whatever the current value of temp, whatever the current value of temp, whatever the current value of temp, add into ans. This is what you do. This is what you do. The simple thing. Okay. Now suppose if I choose yes, now this case will happen. I will reach end of the array. Whenever I reach the base case, this is where I will reach the base case. यहाँ पे ये मेरे को base case की तरफ लेके जा रहा है. This is what taking me to the base case. When I will reach the base case, I will return no. Then I will have a yes wala choice left. I will have a yes wala choice left. Yes or no? I will have a yes wala choice left. This is what that why you reached a base case. You reached a base case. Now you have yes wala choice left. So what we do in yes wala choice? Whatever your current index pointing to add into your temp vector. This is what you do. Okay. So whatever your current nums index, the current element is nums index. This is what my current element is. Okay, nums of index. Add it into your temp vector. Temp dot push temp dot push back this nums of index. That's what. That is the simple thing. And once you do this again, yes, may again repeat the same pattern. Just repeat the same pattern. Control C, Control V. Repeat the same pattern. That's it. That's what we do. A simple recursion code, and eventually our logic will run. And let's just see this works or not. ANS temp nums. ANS temp nums. Okay, ANS dot push back. What happened? Okay, this ANS is actually a vector of vector. It is not a vector. It is a vector of vector. It is a vector of vector. Vector of vector. This is what it is. Okay, accept it. Let me just submit it. It got submitted. Will submit it eventually. Yes. Now, what is the time complexity? What is the time complexity? If you clearly observe, we are storing at least, at most, sorry. If I just try to, where the console? Okay. Here, if I talk about the space complexity, I am storing what is the space complexity of it. The space complexity is very simple. The space complexity is very simple. You are given an array. Okay, it is 1, 2, and 3. Okay, this is what you have been given. The total amount of subsets will be generated will be 2 raised to power 3 because you have 3 elements. 2 raised to power 3 subsets, which is eventually equals to 8. So in your ANS vector, you have total 8 subsets. The total overall space complexity will be equals to overall will be equals to 2 raised to power n, because you are storing 2 raised to power n subsets, plus you are calling, there will be a recursion stack memory. Recursion stack memory also will be occupied. What is this recursion stack memory? This is very important thing you need to know. At every index, whenever you are doing this, 2 raised to power n is fixed. This is the thing which is fixed. Plus recursion stack memory. At most, you are calling your array n times. Suppose here I have given this 3 elements. What is this? I have given this 3 elements 1, 2, 3. So at most I am traversing 1, 2, 3. So this recursion stack will take around big of n of memory. Okay, that is the thing. So the overall I would say the overall space complexity will be equals to 2 raised to power n plus O of n, and this particular memory is basically this particular memory is basically dedicated to this recursion stack space. Recursion stack space. Explain like this in your interview. It will eventually help. Thank you for your watching this video. This is a very long video, I know, but this problem needed a little bit amount of time to explain it. And I will, in the next video, I will try to explain this problem in more depth. But this is what it was. Thank you.